Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes. Thank you.
Yes, sir, you're audible. Your screen is also visual.
Yeah. So in yesterday demo session, just I was briefing you about what is big data, why Hadoop and Spark, drawbacks with the current databases, right? Hadoop and Spark advantages. Yes, Hadoop. Hadoop is meant for two things. Hadoop is providing two services, right? Hadoop is meant for storage and processing. It is meant for storage, and secondly, it is meant for processing. For storage, Hadoop doesn't use any database. It uses a kind of file system called Hadoop distributed file system. And for processing, it is using an execution model called as MapReduce or Spark. Yes, Hadoop is meant for both storing and processing. For storing HDFS and for processing MapReduce or Spark. Drawbacks with the fine. Hadoop is meant for batch processing. Hadoop is meant for batch processing, batch applications. Hadoop is not for online applications, it is for batch applications. There are two types of applications, right? Yes. There are two types of applications. There are two types of applications. First one, online applications and batch applications. Online applications, right? User interactive applications. User interactive applications. User interactive applications means here user gives the input. Here user gives the input. Example of this online applications, right? A booking, for example, making an online transaction. Online money transaction, right? So here user should give the input compulsorily. User gives the input. Observe this example one, right? Secondly, booking a movie ticket. Booking a movie ticket. Making a online money transaction. Booking a movie ticket. Second, for example, batch applications. Batch applications, right? Yes. User non-interactive applications. User non-interactive applications, right? Here non-interactive application. Here user is nowhere required. Here user is nowhere required. Example of this batch applications, right? For example, railway ticketing PNR status. Currently, okay, PNR status means currently your waiting status is 200. After 1 hour, it is 150. Tomorrow morning, it is 100. Tomorrow evening, it got confirmed. Means here, user has nothing to do here, right? User has nothing to do. Here, everything is happening in the background, right? It is happening in the background in automated fashion, right? That is one, right? And also batch application. Credit card statement generation for millions of customers. For millions of customers, right? Yes. And also like a phone bill statement, right? Phone bill generation, right? For millions of customers. All these are the batch applications without the user, without user giving the input, these are going to happen, right? Most of these banking applications or financial applications or batch applications, right? Yes. Okay. Even stock data, everything, right? Stock market, everything, this is comes into batch. User non-interactive applications, user non-interactive. Most of this, I said, most of these financial applications, most of these banking applications are batch applications. Okay, two types of applications, online and batch application. Hadoop is only for batch applications, not for online applications, right? Yes. Drawbacks with the current databases, right? I was discussing drawbacks with the current databases. So most of the databases, very less storage, no parallel processing in most of the databases. If volume increasing, right, speed decreases. If the volume, right, here, select a total amount from sales one, which has 10 records. Select a total amount from sales two, which has 1 lakh records. Select total amount from sales three, which has 1 crore records, right? Which query is executing faster here means the first query, because total amount of 10 records, total amount of 10 records only, right? Total amount from sales to 1 lakh records. Total amount from sales three, 1 crore records. Here, complexity increases, right? Speed decreases. Complexity increases, speed decreases, right? Mm. Observe here, for example, real-time processing is possible through Spark. Real-time processing we do by using Spark, PySpark, right? Yes. Spark can perform this real-time processing. So as part of the course, right, we'll be discussing both Hadoop and PySpark. So using PySpark, you can perform real-time processing. And here, complexity increases, speed decreases, right? Total amount from sales one, total amount from sales, okay. Standard deviation from sales one, right? Which query executes faster among these three? Total amount or average amount or standard deviation of amount means as compared to the first query, second query is taking more time, because average amount is a two-step process. First it calculates sum of amount, later average amount, right? Standard deviation of amount, lot of internal processing is required. Databases can handle Databases can handle only structured data. The major drawback with the databases is they can handle only structured data. They cannot handle unstructured or semi-structured data, right? Yes. Yes. Now, before I go with Hadoop advantages, you need to know something about this or Hadoop architecture. But as of now, I'll give overview about it, but later I discuss in brief about Hadoop architecture, right? Yes. Hadoop doesn't follow Hadoop doesn't follow client server architecture. It doesn't follow client server architecture. Hadoop doesn't follow client server architecture. Hadoop follows it doesn't follow client server architecture. Hadoop follows master slave architecture. It doesn't follow client server architecture. It follows master slave architecture, single master and multiple slave architecture, right? Hadoop, what do you mean by Hadoop cluster? What do you mean by Hadoop cluster, right? Yes. Group of nodes. Group of nodes. Nodes means CPUs, we say. Nodes means like CPUs, systems. Group of nodes, CPUs connected in a network. Connected in a network. There are two types of nodes. There are two types of nodes. First one, master node. Slave node. So within the master node, we have got right name node. Within this slave node, we call data node. Observe this diagram, right? Yes. Hadoop is not for client server architecture. It's for master slave architecture. Means Hadoop is not for online applications. Means if you're giving a request, giving response, not for that, right? Hadoop follows a single master and multiple slaves. This is a single master and multiple slaves architecture. So this we call it as a cluster, group of systems connected in a network. We call it as a Hadoop cluster. That this is called a master node. Within the master node, we have got what? Name node. And this we call it like slave nodes S1, S2, S3. This we call it like slave nodes or data nodes. Slave nodes or data nodes. Observe master node and these are slave nodes or data nodes. Okay. Why we are calling this as data nodes? Because data stored by the slaves, data processed by the slaves. Data stored by the slaves and data processed by the slave nodes. For example, I got a file. In Hadoop, data is stored in the form of files. In databases, data is stored in the form of tables. But in Hadoop, data is stored in the form of files. F1.txt file. Assume system 1 capacity 1 TB, system 2 capacity 1 TB, system 3 capacity 1 TB. F1.txt, the file size is 2 TB. Assume it is 2 TB. The file size is 2 TB. This 2 TB cannot fit into any of the system S1, S2 or S3, right? It cannot be accommodated by S1 or S2, S3 because their capacity is 1 TB, 1 TB, 1 TB. So in Hadoop, in any bigger file, a bigger file or bigger data objects, it will be divided into smaller parts. We call them as blocks. So this smaller, each part will be stored across one system. S1, S2, S3. So bigger data objects are bigger, the files will be divided into smaller parts. Each part will be distributed across multiple systems and are processed by multiple systems parallelly. Here, two advantages you can see. Here you can observe two advantages. One is data is distributed across multiple systems. Data is distributed across multiple systems and data is processed by multiple systems parallelly. Data is distributed across multiple systems and data is processed by multiple systems parallelly, right? Yes. Okay. So two advantages you can see. So parallel processing you can observe and distributed storage, right? So it's a cluster, right? This everything taken care by Hadoop cluster only. You no need to perform anything. Just you need to see into it is divided into blocks. What should be the default block size? Okay, it is going to be divided into fixed size blocks. What should be the size of each block? You need to decide. You'll be deciding. Okay. Master node responsibilities, slave node responsibilities. Master node responsibilities and the slave node responsibilities. Slave node responsibilities are two. Slave node responsibility is storing data is the first one. Second one is processing data. When both storing of data and processing of data, everything is done by the slave node. What master node is going to perform? Master node, right? Yes. Observe. This is master node. So it is a T1 task assigned to S1, T2 task assigned to S2, T3 task, T1 task, T2 and T3. So master node assigns tasks, task assignment. Master node responsibility is task assignment. Any task given by the master should be executed by the slave. Task assignment. Second is whatever task you are assigning should be equally assigned among all the slaves. Load balancing, balancing the load balancing, right? And third one is fault tolerance. What do you mean by fault tolerance is one second. Fault tolerance. Observe this diagram, fault tolerance. If multiple tasks, three tasks are executed by three slaves, S1, S2, S3 parallelly. Suddenly, three tasks are executed by three systems, three slaves. Suddenly, if any one slave goes down, as they are machines, right? While multiple tasks executed by multiple systems, suddenly if any one system is goes down, then the task, then the T2 task of that which should be assigned to any of the other slave. This process is called fault tolerant. That is taken care by master node only. Next, health monitoring. Fourth is right. Health monitoring. Health monitoring means master node will have the health status of each and every slave node before assigning the task, right? It will check the health, will have the health status to whom I need to assign the task. Okay. Later I discuss in brief about these things, right? About this architecture. We have got a lot of discussion like storage architecture and processing architecture. So this master and slave nodes. Okay, based on this discussion, right now, come back to this Hadoop advantages. Unlimited data storage is possible, right? Unlimited Hadoop advantages, unlimited data storage is possible because of horizontally unlimited scalability. Horizontally, yes, horizontally unlimited scalability. Because it has got a feature horizontally unlimited means horizontally unlimited number of slaves can be added. There is no limit on the number of slaves. For example, if you're running a business, for example, if you're running a business, right? If you're running a small business, for example, you got some slaves. Your business has increased, your customers are increased, your branches have increased, your data is increased, right? Still, you cannot go with the same number of. So you need to keep on increasing the slaves also horizontally. You should keep on increasing the slaves horizontally. That is what horizontally unlimited scalability. Horizontally unlimited number of slaves can be added as the data is as customers increased by 100 times, data increased by 1000 times. You cannot go with the same number of slaves. So we need to increase the slaves horizontally, right? Yes. Very high speed processing, very high speed processing because of parallel processing. Because of parallel processing. A labor example, right? What is parallel processing and non-parallel, right? Yes. For example, non-parallel and parallel. One person preparing one item, taking 1 minute. The same one person preparing 10 items takes 10 minutes. The same one person preparing 100 items takes 100 minutes. But in the case of parallel processing, one item 1 minute, 10 items also 1 minute, 100 items also 1 minute. Because here 10 persons preparing 10 items, it takes 1 minute. 100 persons parallelly, they're preparing 100 items, takes 1 minute only. That is what parallel processing. There we say persons, in our terminology we say systems. Parallel processing can handle all varieties of data, structured, unstructured, and semi-structured, right? Can handle all varieties of data, right? Structured, semi-structured, and unstructured. open source. It is an open source, right? No licensing is required. Cost cutting. Commodity hardware. Commodity hardware means Hadoop can be installed. Hadoop can run on any hardware configuration. Doesn't mean that it should have that highly configured, right? Yes. So these are the main advantages, mainly like unlimited data storage, very high speed processing. So we have seen, right? Uh, Processing point of view, Hadoop is proven in the market. Yahoo has conducted a test to check the speed of different databases by taking a table of 100 TB consisting of 1024 columns. So sorting based on 16 columns, not on a single column. So time taken by different databases. Oracle has taken 3.5 days. MySQL has taken 6 days. Teradata has taken 4.5 hours. Netija has taken 3 hours. But finally, Hadoop has taken only 4.2 minutes. These have taken days and hours, but Hadoop has taken minutes of time. But still, Spark has got very high speed. Both Hadoop and Spark combinedly, they can process this data at a very high rate of speed. Yes. So this is Hadoop is proven, right? Processing point of view. Not only processing point of view, even like storage point of view also, it is proven in the market. For example, we can ask why databases I've got a query. Yes. Why databases like Oracle won't support unlimited storage. Why databases like Oracle won't support unlimited storage? Why only Hadoop can perform? Means, observe here. If you talk about this databases, right, like Oracle, even this database like Oracle, you see, we can go with the multiple systems, multiple slaves. So, but there is a limit on them. Databases, max limit on the number of slaves. Max limit on the number of slaves. Max limit on the number of slaves. First, for example, database like if you talk about this Oracle database, right? Max limit Oracle can go with maximum 256 nodes CPUs, right? It can go with maximum 256 nodes or CPUs. MySQL can go with only MySQL, right? Yes. Can go with maximum 54 nodes only. But MySQL Express, it can go with the 256. Talk about this SQL server also, it can go with the maximum 256. Even DB2, it can go with 256. DB2. Okay. Oracle, it can go with the maximum 256 nodes. Once it gets filled, right, it cannot support data further. Just like your mobile phone. Mobile phone, it is given, for example, for mobile phone, you are given internal storage, assume 64 GB internal. If all the 64 GB internal is filled, what happens? The performance of your phone degrades, right? In the same manner, if all the 256 nodes gets filled, the performance of the Oracle degrades, of the system degrades. Sometimes the system even hangs. Sometimes it won't even start. But You have got some data, we have got some databases, specialized databases used for data warehouse purposes like Teradata. They can go with 512 nodes or CPUs, right? And Netija, another specialized database used for data warehouse purpose, can go with 512 nodes. Vertica also, right? Vertica can go with 512. They are also used for data warehouse purpose, but currently Teradata and Netija, they are supporting 1024 nodes. They're supporting 1024 nodes. Okay, but there is no limit. But there is no limit on the number of nodes. There is no limit on the number of nodes that Hadoop can have. But there is no limit on the number of nodes that Hadoop can have. The Hadoop can go with any number of nodes, horizontally unlimited scalability. Yahoo when first time implemented Hadoop. Yahoo when first time implemented went with 4,000 slaves for storing its data. Currently, Yahoo going with 12,000 slaves for storing its data. Facebook, right, when first time implemented Hadoop. Facebook, when first time implemented Hadoop, went with 8,000 slaves, went with 8,000 slaves for storing its data. Currently, it is going with currently Facebook going with 42,000 slaves for storing its data, right? So Hadoop is proven storage point of view with unlimited number of slaves. Horizontally, unlimited number of slaves can be added. And processing point of view also, just I showed right example with very high speed. So today, most of these ETL kinds of projects are getting migrated to Hadoop environment, wherever we see like huge data is involved, right? So yes. So in the last class, I was also giving, I was discussing about Spark, right? PySpark. Why PySpark? Necessity for PySpark, real life usage of PySpark, right? Yes. I said Spark, very high speed processing, has got in-memory computation, storage and processing both happening at within this memory level, right? So as compared to the other technologies, right? A Spark, PySpark, very high speed processing technology. It's processing huge data at quick time, right? It's a open source distributed cluster computing framework, which is introduced by Apache Software Foundation, right? Yes. One second. So this is what I was discussing in the last class. So yes, the engine for big data analysis, processing and computation. So why PySpark means? So it is a Python API to use a Spark, the cluster computing system which is used for big data solution. PySpark is the lightning fast technology that is designed for fast computation. Right. I said PySpark is one of these demanding tool for data engineers for working with the bigger data sets, huge data, right? And mostly this PySpark used for running distributed SQL queries, creating data pipelines, ingesting data into these databases, and even for ML algorithms. Spark, this PySpark is providing special libraries, right, for this ML and also for graph algorithms and for data streams. This PySpark is providing special libraries for graph data and data streams. Yes. So we see a lot of data is getting generated, huge data, right? The data consists of this hidden patterns, customer preferences, market trends, everything, right? So we need to extract the useful informations from this. So we require some efficient tools to perform these tasks. So, so this it's a flexible tools to crack this big data and gain benefit from this. So PySpark is such a kind of where at a high rate of speed processing the data, right? And combining this Python and Spark is the very efficient for the world of this big data. That's why Apache Spark community has come up with a tool called PySpark, which is a Python API for using Spark. So mostly used where this PySpark is used in this real life usage, like in the commercial sector. It's for real-time processing in banks and financial fields to retrieve the uh, if you see the social media customer profiles and gaining some useful insights to taking the right decision and in fraud detections in healthcare, in predicting the patient's health conditions, right? Entertainment industry, even like I was saying, right? The popular OTT platform Netflix using this Apache Spark for this real-time processing. It's processing nearly 450 billion events per day. And for e-commerce like Flipkart, Amazon, all this, they are using this PySpark for advertising, for recommendations, right? And even for tourism, right? For advising millions of customers by comparing the other websites, right? Yes. So as part of this course, right? One storage component like HDFS, processing components. I'll be discussing like three processing components I'm going to discuss. Three processing components. One is Spark. The PySpark is the major one. Hive, Apache Hive, and MapReduce. And one NoSQL database I'll be discussing. One NoSQL database like HBase. Today, like NoSQL has got a great importance, right? Schemaless behavior, random access, and also one streaming technology like Kafka I'll be discussing, right? Streaming data means data which keeps on incrementing, data which keeps on generating, right? Capturing the data and processing it. So I said here we got a big data package which includes Hadoop, PySpark, Linux, and Python. So I'll come back to this just to go through this course content once, right? So everything in brief, like big data Hadoop first we'll be discussing with big data Hadoop sources, storage, processing. HDFS is a file system, right? Hadoop distributed file system, the storage part, features, what is name node, what is data node, what is secondary name node, what is job tracker, what is task tracker, metadata management, replications, fault tolerance, and MapReduce. MapReduce processing is a parallel execution model. And one more important component like Scoop. Scoop, right? For importing and exporting operations. The name itself like Scoop SQL plus Hadoop. The first two characters of this and last three characters of this forms a Scoop. For importing data from databases to Hadoop and exporting data from Hadoop to databases. And during this import, we can perform different types of transformations. while importing, right? Let's see, filtering rows, filtering columns, mergings. Working with the different delimiters, grouping, segregation, into incremental import, incremental loading, defining the scoop jobs, right? Yes. And yarn, yet another resource negotiator, yet another resource negotiator. Yes. Yarn, what are the different yarn components? How the processing is going to happen within the yarn architecture? Yes, you need to clearly know about this yarn processing. Even Spark runs on this yarn cluster. NoSQL database, different types of NoSQL in that. We'll be discussing this HBase is one of the no, and one of the important component of Hadoop, right? This Apache Hive, right? In brief, Hive query language, HQL. Difference between HQL and SQL, loading data from files, loading data from HDFS, different types of tables, internal, external, working with unstructured, working with XML, working with JSON data, working with the URL web logs, union joins, inserting from local files, from HDFS files, UDF, UDAF, user-defined functions, user-defined aggregated functions, user-defined tabular functions, partitioning, static partitioning, dynamic partitioning, multi-column partitioning, performance tuning mechanisms, right? And later bucketing, indexing, combination of partitioning and bucketing, combination of partitioning, indexing, combination of partitioning, bucketing, indexing for the better query performance, right? Yes. My more concentration will be on this PySpark. So need for PySpark, real life usage, PySpark RTDs, parallelizing broadcast variables, operations on RTD, steps in RTD computations, RTD persistence, persistence features, PySpark core computations, groupings and aggregations, different actions and transformations, right? One by one, each with the working examples. And coming to this PySpark SQL data frames, different data frame API, right? And here PySpark creating data frame to pandas, row class, column class, select, collect with column renamed where, filter, drop, order by, group by, join, union, a map, flat map for each, fill null, pivot, partition by, right? And PySpark SQL functions, aggregate functions, window functions, date and timestamp functions, JSON functions, read and write JSON, right? Yes. PySpark built-in functions, one by one built-in functions of it. When EXPR, split, concats, substring, translate, overlay, to date, explode, array contains, map keys, map values, rank, dense rank. So in this way, we have got many functions available. I'll be discussing in brief. You don't need to write huge codings here. We have got many built-in functionalities using which we can perform this, right? PySpark external sources working with SQL statements, Spark and Hive integration, Spark and MySQL integration, working with CSV, working with JSON, um, add, addition of new rows, dropping rows, handling nulls, joins, deployment modes, local mode, cluster modes, PySpark applications, right? Stays and task drivers and executors, building Spark applications and pipelines, deploying, and PySpark streaming concepts, integration with Kafka, PySpark ML right? Machine learning library, right? This everything will be discussing, right? And apart from this, will be given if you are choosing this entire package, right? Big data package. So Python also, which includes it in brief, in depth, it will be discussed. Python basics, Python operations, operators, IDEs, integrated development environment, right? I'm going to show you on different IDEs like PyCharm, Jupyter, Spider, Eclipse, NetBeans, VS Code, right? And flow control statements, basic Python, looping statements, strings indexing, string slicing, string functions, string methods, string special characters, collections, list tuple sets, dictionaries, list indexing, list properties, list slicing, list functions, list methods, list addresses, nested list, list modifications, Similarly, for tuples, for sets, for dictionaries, right? Similarly, for list, tuples, sets, dictionaries, functions in Python, different types, categories, arguments, default, non-default, keyword, non-keyword, arbitrary arguments, different types of functions, lambda functions, filter function, map function, reduce functions, right? Modules in Python, modular programming, working with modules, define like importing module, different ways of importing, renaming, reloading, right? Packages in Python, errors and exceptions, file handling, working with different files, object-oriented programming concepts in brief, regular expressions, extracting data from the given data, database connectivity, connecting Python database connection, right? Python data and time OS module, advanced concepts like iterator, generator, closures, decorators, working with CSV, XML, JSON files, right? Working with Excel workbook, Excel data and data analytics, introduction to data science, Python pandas module in brief, NumPy numerical Python in brief, and matplotlib plottings and visualizations, right? So I said these four things will be discussed in brief. Hadoop. So Python will be discussed from Monday to Friday. Any of my Python batch you can attend. So Monday means tomorrow at 7 p.m. there is a batch starting, right? At 7 p.m. and at 8 a.m. in the coming Thursday, right? Morning, if you want to choose either morning or evening, any batch you can attend. Thursday 8 morning batch and tomorrow there is a batch starting, right? Monday to Friday you'll be attending nearly 50 sessions, 45 to 50 sessions on this Python core and advanced. You people can be attending, and PySpark and these things will be on the weekends. Saturday 2 hours, Sunday 2 hours, right? Yes, as I said, it will be from 7 p.m. to 9 p.m. in the coming sessions, coming the timings of this batch. Right. Before yes, Ankit Jain, right? Yes. Before I go with the practical part, I'll be discussing this Linux commands, right? So how much knowledge required for this HDFS for Hadoop commands, working with Hadoop also HDFS commands are there, right? Everything I'll be discussing, right? Everything goes in Linux environment only, right? So the software, not a worry about the software. I'll be briefing you. I'll be demonstrating about the software. I'll be forwarding those things to your Google Drives. Nearly like 5 GB resources I'll be forwarding to you. The fee structure is 15,000 for this entire package. It goes for nearly 12 weekends, 3 months. Okay. So as I said, right, you'll be getting the session videos. 1 second. You'll be getting the recorded each and every session videos of this you'll be getting, right? Soft copy of the class notes for all this, whatever we discussed, right? With clear notes, assignments and tasks to work with, and the WhatsApp group for technical discussions. Or if you get any errors, you can take the snap of that errors and keep in the WhatsApp. No need to wait until the next week, right? Yes. Mostly asked interview questions for all this. Yes. Yes. Any queries you have got anyone, right?
Sir, if you are attending, it's like if you choosing this big data technologies, so Python will be Monday to Friday, means there won't be any weekend sessions, right, sir?
Weekends means the duration of this will be still increased
No, no,
already.
no, no. No, no, no. My question is already we are starting 7 p.m. to 9 p.m. weekends, right? So, and if you are attending parallelly that Python also Monday to Friday, so there won't be Python again, weekends won't be there, right?
Python won't be in the weekends.
Okay, because I'm thinking like it will be overloaded like that, sir. Okay.
Overloaded means on Saturday and Sunday, if you're spending more hours, you cannot go with
Ah,
the bigger hours, right? That's why
yes, sir.
daily 1 hour session will be there on Python, right?
Okay, sir.
So by the time you complete Hadoop, your Python core gets completed, right? By the time you go for PySpark, you'll be in the Python advanced, right? Yes.
Okay, sir. Okay.
Here PySpark requires this Python knowledge. So immediately PySpark won't be started. You'll be started with Hadoop. and you'll be updated with Python in the weekdays. Yes.
Okay, sir.
Sir,
So, do we need to
uh,
convey to them, sir? I want to attend this Python and 7 a.m. or 8 a.m. like that. We need to explicitly convey, or automatically it will be.
No, no, one
Uh,
second. For example, you can check this contact details of this team, right? Online team. Uh,
yes, sir.
yes, 1 second. So here you can see a big message given by this online team about the course contents, about their contact details, if any queries. So Python, whichever batch you want to attend, you can just convey them. So if they will be added your email ID and everything, they'll be making, uh, they will add your email ID to their whatever Python separate batch. So for sending the videos of this Python, right? You need to clearly intimate them which batch you are attending so that that batch videos you'll be getting, right? Daily basis.
Okay, sir. Okay.
So which one evening or morning batch, which Python batch you're attending. So that mail IDs will be attached to that and you'll be getting the videos to that Google Drive. So you'll be getting the videos from the next week onwards, right? So the next week the link will be changing. You are supposed to get enrolled. So you'll be getting videos to your Google Drive from the next week onwards. If anyone have missed the yesterday session, you can check in the chart, right? A big message given by the online team, right? You can see that demo video of yesterday. Okay. And that payment details, everything is kept in the chart. You can check again.
sir,
So some of you do a mistake, right? Even though after enrolling process, you are supposed to send the screenshot of your payment to this DURGASOFT online training at gmail.com. It is mentioned clearly there, right? The mail ID, so that they'll be forwarding the link for the next Saturday's class. Everything they'll be mentioning. Next Saturday, a WhatsApp group will be created. You'll be added to the WhatsApp group for technical interactions or any errors or these things. Yeah, someone was asking a query, right? You can see that yesterday's video in that. Can you see the demo video? A link is given, right? So yesterday's and today's video which will be kept in the YouTube. The link will be shared with you. Yesterday's video link is shared. Can you see in that Zoom chat? Today's video also you'll be getting, right? To your mail. Okay. After,
hi, sir.
yes,
So
go ahead.
Python is required only for PySpark, right?
Yes, PySpark, right? Yes.
And what about the MapReduce or Apache Spark?
So here, yes, Apache Spark only, right? Spark implemented using Python language. Spark can be coded with four languages actually. You can implement it by using Python, using Java, using OR language, using Scala language. So here Python is the mostly used, mostly chosen, right? Spark implemented using Python language. Total implementation goes in Python. So the entire
Okay.
Spark
So
we are
what about
implementing.
MapReduce? It will be in Java or Python?
See, MapReduce, it's a component, right? Whenever Spark was introduced, I was saying here, can you see here? Hadoop is meant for storage, Hadoop is meant for processing. For processing, MapReduce and Spark. Okay,
Uh-huh.
previously, MapReduce was used a lot. Previously, if you see 10 years ago, if you see, totally MapReduce was used a lot. But if you see, only the Java people, Java guys used to attend these Hadoop sessions. They used to update with the Hadoop, right? But because of MapReduce has got a lot of Java coding, later, totally they have removed that Java and it's totally they went into other languages like Scala and Python using Spark. Whenever Spark was introduced, the usage of MapReduce has totally decreased in the industry because MapReduce involves pages and pages of code. Pages and pages of code, right? Huge coding is involved as Java is involved in that. So when Spark was introduced, totally this MapReduce got outdated. So I'll be providing you the knowledge of this MapReduce. So people means it is not at all used at all in the industry currently. Previously it was used a lot, but still I'll provide you that knowledge on this MapReduce.
Okay. Sir,
Now, the only thing is we require Python knowledge, basic SQL knowledge, basic Linux knowledge. So what are the prerequisites means basic Linux, basic SQL and basic Python. Anyhow, you'll be getting the Python knowledge here. You'll be getting the Linux knowledge here and basic of SQL knowledge is required for these things. Right? So you can see that packages for this, especially if we talk like PySpark, Hadoop and PySpark developer, right? You can see if you Google and check the salary packages for this. Will be the salary packages 1.5 times more than the other technologies, right? The same way you need to have the technical skills. That's why we'll be spending more time on this technology, right? So that's why I'm taking 3 months for this. Yes,
So,
Roshan
so
Sahu.
how long it will take, sir?
Hmm.
How many
What is it? How long?
how many days of course?
Course duration, right? It's 12 weekends means 3 months it takes.
12 weekends means 24 days, right?
12 weekends means Saturdays, 12 weekends in a month, 4 weekends, right?
Mm-hmm.
Means 12 weekends means 3 months.
3 months.
Weekends will be attending, but meanwhile, this Python will go for 1.5 to 2 months.
Sir,
Yes.
this the course itself, no, sir. This is recorded session or the weekend one will be live session, sir.
Live sessions. I'll be taking the sessions, right? Every Saturday, Sunday.
Okay, only the Python is recorded sessions, is it?
No. Python also live sessions I'll be taking.
Okay.
But still, this session will be recorded. You'll be getting also the recorded videos also, I'm saying.
Sir, yeah, how many weeks will you cover this one? The except like before PySpark, we have till this one, right? Hive, Scoop, HBase, and Hive. How many weeks? How many weekends would that be covered?
5 weekends.
5 weekends for that. So bucketing, everything will be covered in that.
Yes. Hadoop. See this I have given in the syllabus content, right? Bucketing
Yeah.
and
So
the
entire
combination
syllabus will be covered, no?
in this combination of bucketing and indexing, bucketing and partitioning, different
Yeah.
types of partitioning, indexing, everything, right? You
Yes.
can see that in that Hive is the important component, right? Don't worry about the notes, clear notes, you will be getting it, right? 1 second. Here you can check the notes. For example, so these are the previous PySpark batches. You can see any of this batch, right? PySpark notes. So PySpark introduction, all these PySpark computations, this is all the notes, right? Step-by-step notes of all this.
And sir, for this one, the PySpark, so to understand PySpark, we will need to learn data frames, right? So, in Python, would we be able to cover pandas by the time we start this one?
See this,
PySpark?
1 second, right? Data frames, this Python data frames are different from this Spark data frames.
Yeah, the Spark data frame, so we don't have to understand Python pandas to understand Spark data frame.
So Spark data frames are different from Python data frames. But even in Spark, you can make use of this Python data frames. But whatever we are discussing Spark, it is totally how we create, how to develop is totally different.
Okay.
You no need to have this pandas knowledge, right? Yes.
Pandas knowledge, no? Okay.
Yes.
And sir, will you be covering Kafka also?
Yes, Kafka also I'll be giving.
Just basics or the hands-on too?
So practically I'll be showing you the things, right? Yes.
Okay.
The Hive someone asked, right? Hive 1 and Hive 2. Two things I'll be discussing, right? You can see Hive introduction, Hive, and here in Hive 2, you can see all this in Hive 1. So this partitioning, different types of partitioning, and in this you can see this indexing, bucketing, all this, right?
So like indexing in Hive, can we do indexing in PySpark?
Indexing in
PySpark, like we have the option to index in Hive, right? So can we
indexing, right? See, just like SQL indexing, even in Hive SQL indexing is there.
Yes, HQL they use.
Yes,
But
in HQL we'll be using, but in PySpark it's not required. So we have got the concept of data frames there. Even we have got the concept of data frames. Using that, you can perform the things.
so no indexing is needed. Say, for example, if application requires indexing for quicker access, so can it be done in PySpark?
PySpark has got because of these data frames, they look like table only, right? And
Yes.
it is providing many functionalities, right? Using those, we can perform the things.
Okay.
And even if you want, like we have got the concept of Spark SQL, right? PySpark SQL, if you want to
Yes.
perform kind of querying also, you can perform it. Any kind of pure SQL statements, you can work with Spark SQL.
And when will the batch start, sir?
Next Saturday, from next Saturday, I'm going to start with this, right?
Okay. Thank you, sir.
Okay. Any other queries, right? Anyone? Fine.
So if I learn this, this will be comes under data engineering, right?
Yes.
Okay.
So they have got great demand for this data engineer, right? Yes. So whatever that ETL kind of things, everything will be doing here using components like Scoop, Kafka. Okay. Fine. So you can check that, you can just make a copy that message, right, of this online team, their contact details, the other things, right, and the payment process, everything. So next Saturday, the link gets changed. So you'll be getting the link to your mail IDs. If anyone, if you have not received the link, you can check with that contact details. You can call them. Fine. Okay. So if I'm done with the queries, if there are no other queries,
Sir, one last question, sir.
yes, go ahead.
Is there any possibility explaining one application in cloud, sir?
Yeah, I can do, not a problem at the last.
Yeah, sure. Thank you, sir.
What is that Roshan Sahu? PySpark also will be having, right? What is that?
Sir, laptop will be able to install the environment, sir.
Yes, yes, everything I'll be demonstrating, right? Anyone,
Okay.
any, whatever might be your configuration.
Okay.
Okay. So I'm signing off for now. Meet you next Saturday, right? So more will be going with this Hadoop discussion, right? And meanwhile, okay, you can attend these batches of this Python, right? So tomorrow at 7 p.m. there is a Python, and at Monday, that is on Thursday at 8 a.m. there is a Python. Those who are, so you can enroll and just attend these things, right?
Python, when is it starting the batches? Tomorrow onwards.
Tomorrow in the evening 7 p.m. and one more morning batch. It's going to start on Thursday on 8 a.m. Right?
Thursday, 8 a.m. Okay. Sir, if next week, no, we don't have something like for Python next week onwards, sir.
It's almost Thursday and Friday. Okay, you'll be. You can, if you are missing the session, you will be getting the recording. You can go through that recording, right? If you are missing for a part of time,
Okay. Okay, sir.
recorded session of that each and every session you'll be getting.
Okay.
Fine. Okay. So thank you all for your time. Meet you next Saturday discussion on these things, right?
Thank you, sir.
Sir, I already paid, sir, but I didn't receive any link, sir.
Uh, so Python sessions you can attend, right? You can intimate them. And for Hadoop, right? By next Thursday, you will be getting the link for Saturday's class. By Thursday or Friday morning, you will be getting the link for this Hadoop.
Okay, okay, sir. Could you please intimate to them? Thank you,
Yes.
sir.
You can you can have their contact details, right? If anything, if you're not got, you can contact them.
Okay, sir. Okay.